Hi and welcome to this lesson. First of all, please subscribe to the channel and share this video with someone who might find it just as useful as you. So today we're going to talk about the topic measurements, and all you need to know lies in these four shapes. You know them already. This is a square, a rectangle, triangle, a circle. You know that a square has four equal sides. Yeah. So if you want to find the area of this square, you're just gonna multiply one side by another. That's why the area of a square is equal to side squared. And then for the rectangle, it's the length multiplied by its breadth. That's the area of the rectangle. And for the triangle, the area is equal to half the length of the base. This is the base, like the part that the triangle is sitting on, and then the height is the perpendicular line drawn from the base to the vertex. So this is the height. And then for the circle, the circle has its center and a radius. This is our radius. So the area of the circle is pi multiplied by the radius squared. So it's pi multiplied by the radius multiplied by the radius, and that's it. That's all you need to know. If you know this, you'll be good. Now let's move on to 3D shapes. Now all these shapes that are here are all 3D shapes. Like you've got your cube, you've got a cube right there, and now all these shapes that are here are all 3D shapes. Like you have your cube there, your cuboid, your hemisphere. Therefore, if you just come to a sphere and cut it in two halves, you're gonna get a hemisphere. I mean, two hemispheres. And you have your cone, your cylinder, your square-based pyramid, and a fish. I'm just kidding. There's no fish. No fish. Don't consider that. Now let's look at them one by one. I mean, these aren't all of them. These are just the basics ones, and that's the whole point. I want you to know how to get the area, I mean the surface area and the volume of each and every shape. Like if they just give you a shape like a donut, yeah, you can get the surface area and the volume. Now let's take a look at each one of these shapes. Okay, so first up we're gonna find ways to calculate the surface areas of all these 3D shapes. I put these two together because they are very much the same shape. So it's your cube or a square prism and your cuboid width, which is just a rectangular prism. So what you need to know first is that the surface area is, I don't know how to explain this, but is the total area of all the sides that you can see. Like the cuboid has it is made up of 6 squares. It's like 6 squares glued together, if you know what I'm saying. And then the rectangle, I mean the cuboid, on the other hand, is just like rectangles and a square and 2 squares. I'll show you what I mean, but I hope you get the point. Like it's the area of all the sides that you can see. Yeah, that explains it. Like you can see 6 squares from this one. So to get the total surface area, remember at the first so to get the total surface area, remember from the first part of this lesson we learned about the square. Remember? Yeah, this is where the square comes in. So the surface area of a square is just side squared. but now we have 6 squares on the surface of this cube. So this total surface area of a cube has to be 6 times the area of a square. That's it. I mean, it's just 6s squared because we have 6 squares there. I hope it makes sense. And you can write it as 6l squared, if you know what I mean. Now let's get to the cuboid. If you still remember, at the beginning of the lesson, I drew a rectangle, and I said this is the length of the rectangle and this is its breadth. But this time, because we have a 3D, like a 3D cuboid, we're gonna call size like this. So this will be the length and this is the breadth, and now we have a height. Can you see this? So the total surface area is the area of each and every side of this cuboid. So we have this side. This side is the same as the side on the other side, so this side is the same as this one. So we can just say the total surface area of this thing is 2 multiplied by the two sides that I just showed you, and their area will be length times height. So it's length times height, okay, plus. Now if you look at this from this angle, you have sort of a square here, right here, and another one corresponding to it on the other side. So if we do this, so this is the breadth. Remember, don't forget that this is the breadth. So the area of this thing will be like, it's 2 of those, so it's the height multiplied by the breadth. It's the height multiplied by the breadth. I mean, let's do it like this: the height multiplied by the breadth. And the final side is just the one on the top right here and the one on the bottom. So it will be plus, let's get rid of this, this. So it's plus 2 of, so the area of this top part is like the breadth multiplied by the length. The breadth multiplied by the length. Some people call the breadth the width, so this might be maybe your teacher showed you this as W. It's still okay, don't fight me or your teacher. So that's pretty much it. So the total surface area, if we write it clearly, it's just going to be 2, this is just 2 LH plus 2 BH plus 2 BL. You can also take the common factor of 2 there and write it this way. So it will be 2 into, you take this part, it's LH or WH, plus 2, you take this part right here, it's BH, plus the last part, which is the HL, Don't mind my handwriting, it's not my handwriting actually. So we are done with these two. We are starting with the surface areas. Next up, we have got this cylinder, or next up we have the cylinder, or the cycle prism. if you want to get the surface area of this shape, it's a 3D shape, you need to disintegrate it first, and if you kind of disintegrate it, you'll end up with two circles. So you'll end up with two circles. It's the circle on the top, this one, and the circle on the bottom, and the last part is this part that is just wrapping around the shape. And if you unwrap it and cut it down, it will resemble in a rectangle, and the area of the rectangle is just the length multiplied by the breadth. But in this case, the length, I mean this distance from here to here, is also the distance around the circle, and the distance around the circle is called the circumference, which is also equals to the part 2, it is equals to 2 pi r, okay, or pi multiplied by the diameter. So 2 times r is just equal to the diameter, that's why it's 2 pi r. So we are done. To get the surface area is just to calculate the areas of the shapes that we can see on the outside of a shape. So first of all, we have got this rectangle. So the total surface area of a cylinder has to be, you know, the area of this rectangle, which is just the length multiplied by the breadth. But in this case, we will call this height. It's the height of the prism, and we will also have the radius right there, which will be the same as this radius from this circle, because this circle is the same as that one, and this one is the same as this one. These are identical circles. So this will not be the breadth, it will be height this time. And we told you that the length of this rectangle is equal to the circumference of this circle, so it's 2 pi r. So we are going to have 2 pi r multiplied by the height. This is the area of this rectangle part right here. Let me change the color real quick. So this height is just it will be the breadth, it's this part here, and the length is the circumference from here, and it's equal to 2 pi r. That's why it is right here. Let's get rid of this. What you are left with now is just the area of these two circles, and because they are identical, you can just say, let me change the color, you can just say it's 2 multiplied by, what is the area of a circle? We said it in the first part of this lesson, it's pi multiplied by the radius squared. I'm sure I explained in a way that you get it, right? The surface area is the area of the shapes on the outside of the entire shape. Like we have this part right here. Actually, I explained this. We have two circles, one on the bottom and the other one right here on the top, and then this part that is wrapping around, which is basically a rectangle, but the length of this rectangle is also the circumference of the circle on the top or the bottom. So that's why we use the length as the circumference, which is 2 pi r. Well, you get it. This is the area of this rectangle, and this is the area of a circle, but we multiply it by 2 because we have two of those circles, one on the bottom and on the top. Okay, and the reason why I included this one is an open cylinder, so it just have one circle on the bottom, and then the top has no surface, like it's just a hole, it's hollow like a glass. They can trick you like this and say calculate the area of the total surface area of a drinking glass, so it's open on the top. So what you're going to do is just get the area of the sides that you can see, like the surfaces. So you still have your rectangle, so you're just gonna copy this part as it is. So it's 2 pi r h, okay, but this time you only have one circle. So instead of writing this 2, you just cancel the 2, and let me get rid of this. You just cancel the 2 and you'll be left with the area of a single circle. This is 2 because you have 2 circles, and this is 1 because you only have 1 circle. So I hope we are done with the surface area of cylinders. I hope. Up next we have the hemisphere and a sphere. So hemi means half, so this is basically 1/2. If this was S, if this sphere was called S, this would be half of S. So it's just the half of this. Okay, let's get rid of that. So what you need to know now, the surface area of a shape, I've said it before and I'm gonna say it again, it's just equal to the area of the shapes you can see. So in the case of a hemisphere, what you can see is a circle. I'm sure all of you can. So this circle on top right here, can you see it? This circle right here, this is a circle right there, right there, it's a circle. Okay, it has its own radius and stuff. So yeah, that's the radius. So let's just assume that that circle on top is this circle, and the other part that you can see is just this curvy surface right here, which has not really, it does not have a definite shape. So yeah, you're just gonna take it as it is for now. So the surface area of a hemisphere, we're starting with the hemisphere now. I'm gonna show you why. So the surface area of a hemisphere is just equal to the area of the circle. So the area of the circle, we've said it before, is just pi r squared. Okay, and for some reason the surface area of this curvy part right here is equal to, let me change the color so that you can see it clearly. The surface, the area of this curvy part, the one that wraps around the shape, is equal to twice the area of a circle. It's not really like that because, you know, it comes from the fact that this is also a radius from the center of the thing to its bottom is also the radius. But what you need to know is that the area of this curvy part is equal to 2 times pi multiplied by r squared. So that will give you the total surface area of a hemisphere. So it's the area of a circle, this one on top, and the area of the curvy part right here. Let's get rid of this. Okay, now let's come to the sphere. Now let's come to the sphere itself, the sphere. So the surface area of the sphere, now I told you that if you just kind of cut it in half, you're gonna get a hemisphere. But what you can see from this sphere now is just an egg, kind of. But what I'm trying to say is that you just have 2 of these curvy surfaces. These ones, yeah, these ones. It's 2 of those. If you cut it in half, you're gonna get 2 hemisphere, and the surface that you can see is just 2 of those. So the total surface area of a sphere is equal to twice the surface area of this curvy part right here, because you have 1 of those and 2. Okay, so it's just 2, excuse me, pi r squared. If you simplify this further, you are going to get 4 pi r squared. The goal here is to understand, not just cramming things, you know. And yeah, I hope you understand that it's just 2 times the curvy surfaces over there. Now let's move on. Now let's do the cone. So our cone friend right here has a circle on top. You can see it, right? I mean, this is a circle and the center is right there, and this is pretty much the radius. It's not straight, I'm sorry. And this height from there stretching down here, it has to be straight. Mine is not because of some reasons. We're gonna call it h. Okay, so for the surface area, you just calculate the areas of the surfaces that you can see. So you can see a circle right here is this one, okay, and this curvy part that if you draw it, it's gonna look something like this. Okay, so the total surface area of this cone is actually equal to the surface area of this circle. So the surface area of that circle on top will be just pi r squared. Okay, and now you're gonna add it to the area of this curvy part right here, which for some reason, and I'm sorry I didn't mention this, so we have got the radius, the height, and we have this slant part right here, like this distance from here. It's the slant height. It's called the slant height. Sorry, I cannot draw it quite clearly, but yeah, you kind of see it, right? Let me just fix this real quick. Yeah, so it will be this side right here on the edge of our cone right here. This part on the edge of our cone, it's called the slant height. So your total surface area of this cone is equal to the area of that circle up on the top plus the area of this part, the curvy part. It's curvy, it looks like this. So for some reason the area of this part is equal to pi r multiplied by the slant height. Okay, some books might show it as an h, a lowercase h, and this height that we referred as, and then they'll show it at h. They keep the letter h. So yeah, this is pretty much the total surface area of a cone. So the last shape we're going to do on this lesson is the square based pyramid. It's a right pyramid. So all pyramids, I mean all the right pyramids are the same, so I'm just gonna do one and then you can do the rest. Okay, so if you want to get the surface area of this, what you can see here is that we have got 4 distinct triangles. So that's 1, 2, 3, and the 4th one right over there. And down on the bottom we have got a square, a single square. So it's called a square based pyramid because on the base of it we have a square, and on the top we have yeah, we have 4 triangles. So yeah, so what you're going to do is just to see the surface area, the total surface area is the surface area of the square. So you have got your square. So this is also the base of a triangle, base of the triangle, and then you have got your heights right here, the heights of the triangle. So basically what it is just that the area of a square is just its side multiplied by itself. So it's just b squared because it's going to be b multiplied by what? By b, the base of the triangle. You can call it whatever you want, like an s or something, but I prefer to call it a b because it's also the base of the triangle. So the surface area of, let me change the color, the surface area of that square is just b squared plus Now that you have 4 triangles, we're just gonna say 4 because they are all identical. Okay, it's just 4 into, and then you just calculate the area of one, like it's just base multiplied by height, and this will boil down to like b squared plus this 2 divided by that. If you have your truth, it will be 2bh. Okay, now where it will get tricky is when the base of the shape is like a rectangle. Okay, it might be confusing to some people, but this triangle right here will have the same properties as the triangle right here, and then this one will have the same properties as the one on the other side. So if, let's say, this is a rectangle, you're gonna have your length and then the breadth. So instead of just saying 4 into half bh, you're going to say, because it's a triangle, it will be lb, I mean length times breadth is the triangle on the bottom, I mean the rectangle on the bottom, plus 2 1 over 2b, yeah, the breadth. Okay, plus 2 into 1 over 2, this time it's, I mean lb, so it's lh. I forgot to put an h right here. You must not forget to put it on your answers. So it's just lb plus bh plus lh. This is the total surface area of a rectangular based pyramid, pyramid. So we are done with the surface areas. Now let's do the volumes. So we're gonna group this into 3 distinct parts. So the first part of volumes, these are volumes now, volumes of shapes, 3D shapes. Only 3D shapes can have volumes. So the first batch over here is the batch of prisms. So a prism is a shape that, the shape of the roof or the top part is the same as the shape of the bottom part. So you can see a cylinder has a circle on top and a circle on the bottom, and a cuboid is a rectangle on top, a rectangle on the bottom, a cuboid, a square on top, square on the bottom. So because this is a cube, so all sides are the same, you can call them whatever you want. Most people call them L. So the volume of the cube. In fact, the volume of every single prism is equal to the area of the bottom shape multiplied by the vertical height. So for example, if we use the cylinder, we're going to start with the cylinder this time. So this is the shape that is on the bottom side. So we have a square, and then we have it's a circle, and then we have our height right there. So the volume of every prism is the area of the bottom side multiplied by the height. So the bottom side is just a square, it's just a circle. So the area of a circle is pi r squared, and then we multiply it by the height, which is just h. That is the volume of the cylinder. And for the rectangular prism or the cuboid is a rectangle on top. I'm making a lot of mistakes now, I'm sleepy. And yeah, it's the same shape on the bottom. So if this was the length and this is the breadth, the height will be this part going up, so the volume of that thing will be like the area of the bottom part, which is a rectangle. It's LB. Oh my god, it's just LB. Okay, multiplied by the height, it's LBH. You're done. And then for the square, all sides are equal, so it's just side times side, side times side, so it's S cubed or L cubed, as most people call it. Yeah, like the square is L, and this square is also L, so it's L times L times L. It's L cubed. Let's use the appropriate color. It's L cubed. That's the volume of a cube. Next up, we are going to the right pyramids. Now these are what we call right pyramids. A right pyramid is like a shape that has a distinct base shape. Like this one is a circle, this one is a square. So, and then just go to the top, like from the center. This top is direct, so you can draw a vertical line from the tip, and it will end up at the center of the base shape. So this is a cone, and this is a square based pyramid. It's a right pyramid. So first of all, let's address the volume of that. In fact, the volume of every single right pyramid. So the generalization says the volume of a right pyramid is equal to the area of the base shape. Okay, area of the base shape multiplied by the perpendicular height, like the height from the center of the base shape to the tip of the pyramid, if that's what we're gonna call it. So it will be something like this up to there. Okay, that's the H with this capital letter H that we're using. So the area of a base shape is just a circle, so it's pi r squared multiplied by the height. Oh, I'm sorry, it's not that. That one is the one for prisms. So this one is a third of that, so it's going to be 1/3. Yeah, the generalization now changes. It's just the third. It's a third of the area of the base shape multiplied by the perpendicular height. Yeah, so that's the area of every single pyramid. It's a third. I mean, it's 1/3 multiplied by the area of the base shape. In this case, we have a circle, and multiplied by the perpendicular height. So on the case of this shape, the square based pyramid, so the bottom side has a square, so it's just 1/3. I'm not gonna forget this time. 1/3 multiplied by the area of the base part, so it's just b multiplied by b squared. Okay, multiplied by h is b squared, because this is the base of the triangles. Okay, you can just say s squared or L squared, but in the case of a rectangular based pyramid, it's going to be 1/3 multiplied by the area of the bottom shape, which will be a rectangle, so it will be LB this time, multiplied by H. Okay, And a quick note before I go anywhere. So on the prisms, I forgot this shape, like it's actually called a triangle prism. I don't remember the term for it. So this is the height, right? So on the prism side, we say it's the area of the bottom shape. So it's just the area of a triangle. So it's half BH. Yeah, half BH. The h we're talking about is the height of the triangle multiplied by the real h, the big one. So that's the volume of that prism. And then for this total surface area, well, I told you how to do this. We have two triangles, like two triangles, and 1 2 3 and 3 rectangles. So you're just gonna calculate the area of these two triangles, add them to the area of the 3 rectangles on the side. Let's move on. So okay, this time on volumes, let's start with the sphere, the volume of the sphere. So the volume of the sphere, I don't know why, but the volume of this sphere is just equal to 4/3, like 4/3. That's it. Yeah, it's 4/3 multiplied by pi multiplied by r to the power 3 multiplied by r cubed. Yeah, that's it. And because a hemisphere is just half of the sphere, the volume of it, it's kind of easier. You're just gonna say 1/2, so that's the half of that. 4/3 pi r cubed. If you simplify this one, this will cancel that and you'll be left with the 2. So the volume of a hemisphere is equal to 2/3 pi r cubed. And that's it. That's it. You have mastered measurement. And guys, please note this, it's not about cramming the formulas, it's about knowing, because they might come to you and said, oh hey, we want you to calculate the surface area or the volume of this donut, and you're gonna say, what? I've never seen the formula to calculate the surface area or the volume of a donut before. But you have really, if you look at the donut, like paying attention to it, a donut is just an overgrown cylinder. It's just a cylinder, like it's a cylinder. Let's flip it so that you can kind of oh my god, just move it. Okay. This way, you see now, this is your donut. It's just that it has been wrapped around like to cross like this, and that's it. So if you just cut this donut right here, you are going to get like this cylinder, and then you can just calculate the surface area and the volume of the cylinder as I've shown previously. So don't be scared, like they can trick you in many ways. Like they can say yeah, we have a cone right here, and they might do this to you. So they're just gonna take a cone and combine it with a hemisphere. I'm talking from experience, don't think I'm just talking. They might say, oh hey, this is an ice cream, so calculate the total surface area of this ice cream, or calculate the volume of this ice cream. But if you look at it, it's just a cone and a hemisphere, so you can just calculate there. For the surface area though, it's tricky, I know, but it's just the area of the curvy part of the hemisphere and the curvy part of the cone. And yeah, that's pretty much it. So you just calculate the area of the curvy part. I've shown it before, and the curvy part of the cone, but for the volume you just calculate the volume of this hemisphere and the volume of the cone and add them together, and voila, you have got the volume of an ice cream. And good luck on your exams, guys. Oh, before you go, please subscribe and leave a like on this video. Thank you. Bye.